Alright, so Keeper 4.1, Introduction to Power Series in Class Problems. Alright, so from the notes, you should have seen that we build our power series using the geometric sum. So that means that if I have a sum, n equals 0 to infinity of x to the n, that's geometric, so I can use my sum formula of a sub 1 over 1 minus r, and I would get something like 1 over 1 minus x. So that's the formula that we're going to use, or the idea that we're going to use throughout this lesson. And every single problem that we have, we're going to start the problem by using this formula. So if I look at number 1, we have 6 over 1 plus x to the 4th. And so the first thing I'm going to do is I'm going to rewrite this to look more like the geometric series. And so in order to do that, I need to make sure that this is a 1, which it is. And I also need to make sure this is minus. And so when I rewrite my f of x, I'm going to get 6 over 1 minus negative 7x to the 4th. Alright, so now I got my 1 in front in my denominator, and I'm subtracting off something. And so again, all I do is I build this series starting with that geometric idea. So I start with the 1 over 1 minus x, which I know is just the sum, n equals 0 to infinity x to the n. Alright, so then I just start to build my function off of this idea. And I always start in my denominator. So I have in my function 1 minus negative 7x to the 4th. So that means where I have this x here, I'm going to replace it with negative 7x to the 4th. So I'm going to write 1 over 1 minus negative 7x to the 4th. And that's going to equal the sum, n equals 0 to infinity. Everywhere I see an x, I'm going to put the negative 7x to the 4th. So instead of x to the n, I'm going to say negative 7x to the 4th to the n. Alright, so the last thing I need for my function is the 6 in the numerator. So I'm going to multiply the function by 6. So I get 6 over 1 minus negative 7x to the 4th. And again, all I did there was multiply by 6. So when I write my summation, I'm going to multiply that by 6. So I get 6 times negative 7x to the 4th to the n. All I did was multiply by 6. Now basically we have our power series at this point. It's just not in the power series form. And generally when you write your functions in power series form, you separate each individual piece. And so I'd have the sum, n equals 0 to infinity, 6 times negative 7 to the n times x to the 4n. And so now I have it in my power series form. Now the next thing they asked us to do was figure out our interval of convergence. And so if you remember, for geometric series, whatever your r is, the absolute value of that has to be less than 1. And so in this case, we have our r is the piece that's being raised to the n, which is the negative 7x to the 4th. And so I know that the absolute value of negative 7x to the 4th has to be less than 1 for it to be a geometric series in order for it to converge. And so that tells me that 7, absolute value of x to the 4th, has to be less than 1. Or absolute value of x to the 4th has to be less than 1/7. And then if I fourth root both sides, I get absolute value of x has to be less than 1 over 7 to the 1/4. And again, using properties of absolute value, that simply means that negative 1 over 7 to the 1/4 has to be less than x, has to be less than 1 over 7 to the 1/4. And that would be my interval of convergence. Alright, so the next problem, in example 2, we have f of x equals x cubed over 3 minus x squared. Again, before you work any problems, this has to be a 1 and this has to be a minus. We're good on the minus this time, but we need to make this 3 a 1. And so we're going to do that by factoring out the 3. So I have f of x equals x cubed over 3, 1 minus x squared over 3. And again, I always want to look back at it and check, make sure that is actually equal to my original function, which if I distributed the 3 back in, it would be equal to my original. Alright, so once I have it in the correct form, again, I'm going to start building my sequence. using my original geometric. Alright, and once I have that original geometric, I build it out. So again, I'm going to start with this whole 1 minus x squared over 3. And so that means everywhere I see the x, I'm going to put x squared over 3. And that means when I write my summation, same thing, wherever I see the x, I'm going to replace it with x squared over 3. Alright, next thing I'm going to do, or next thing I notice, is that really all I have is this function that I wrote is really just being multiplied by this x cubed over 3. And so I'm going to rewrite my next step as x cubed over 3 times 1 minus x squared over 3 equals the sum, n equals 0 to infinity. Again, all I did was multiply it by x cubed over 3. So x cubed over 3 and then times what I had before. Now again, technically I'm done, but it's not really written in the power series form. I want everything to have its own separate base. And so I'm going to start with the x part. So I have the sum, n equals 0 to infinity. I have x cubed and I have x to the 2n. And so remember, properties of exponents says that you can add those exponents. So you'd have x to the 2n plus 3 all over. Here I have 3 to the 1 and I have 3 to the n. So I have 3 to the n plus 1. And there's my power series. Now, to get my interval of convergence, we know that whatever was being raised to the n, which is the x squared over 3, has to be, the absolute value of that has to be less than 1. So I have the absolute value of x squared over 3 has to be less than 1. Or the absolute value of x squared has to be less than 3. Or the absolute value of x has to be less than the square root of 3. And again, using the properties of absolute value, that simply means that negative root 3 has to be less than x, has to be less than root 3, or x has to be between negative root 3 and root 3. And again, that's my interval of convergence. Alright, so the next problem, we have f of x equals 3x squared over 5 minus 2 cube root of x. And so again, I need to rewrite that because I need that 5 to be a 1. Alright, for this to work. So I'm going to take out a 5. So I have 3x squared over 5, 1 minus 2/5 x to the 1/3. So I just changed that cubed root to be x to the 1/3. Alright, so now that I have it in the proper form, I'm going to start building my series. So again, when I build this series, I always start with the original. 1 over 1 minus x is the sum, n equals 0 to infinity, x to the n. Now wherever I see x, I need to put in this 2/5 x to the 1/3. So I have 1 over 1 minus 2/5 x to the 1/3 equals the sum, n equals 0 to infinity of 2/5 x to the 1/3 to the n. So again, wherever I saw the x, I replaced it with 2/5 x to the 1/3. Now the last part of this series, I need to multiply my entire function by this 3x squared over 5. So I get 3x squared over 5 times the 1 minus 2/5 x to the 1/3 equals the sum, n equals 0 to infinity. And again, all I did here was multiply by that 3x squared over 5. So I write that in front, and then I have my 2/5 x to the 1/3 to the n. Now again, technically I'm done, but I need to write it so it looks like a nice little power series. So what I'm going to do is I'm going to rewrite, and I have the sum as n equals 0 to infinity. I see my 3/5. I see 2/5 to the n. And then I also see I have x squared and x to the 1/3 n. So that's going to be x to the 1/3 n plus 2. Alright, so that is my power series. Now I need to figure out my interval of convergence. So again, for interval of convergence, I'm going to take whatever was being raised to the n, which was the 2/5 x to the 1/3, and I'm going to say the absolute value of that has to be less than 1, which means that the absolute value of x to the 1/3 has to be less than 5/2. And then if I cube both sides to get rid of the 1/3, I have the absolute value of x has to be less than 125 over 8. And then that, again, using the properties of absolute value, that tells me that negative 125 over 8 has to be less than x, has to be less than 125 over 8. All right, and again, that's my interval of convergence. In example 4 looks pretty easy because I already have the 1 in front in my denominator and I have minus. So again, all I'm going to do is build this series out. I don't need to rewrite. So I have 1 over 1 minus x equals the sum n equals 0 to infinity of x to the n. Then I need to put in this 8x. So I have 1 over 1 minus 8x. And that tells me everywhere I see an x, I'm going to put an 8x. So I have 8x to the n. And then on top, I multiply that by x. So I have x over 1 minus 8x equals the sum n equals 0 to infinity of x times 8x to the n. Now again, I need to write that in my power series form. So I'm going to separate everything out. So I have the sum n equals 0 to infinity. I have 8 to the n. And then I have x to the n and then x to the 1. So x to the n plus 1. And that is my power series. And again, all that tells me at that point is that I know this thing is going to converge as long as my absolute value of my r, which is 8x, is less than 1. So to write that out, I get absolute value of 8x has to be less than 1, or absolute value of x has to be less than 1/8. That means that negative 1/8 has to be less than x, has to be less than 1/8. All right, example 5. We have negative 12x squared, and then we have 1 plus 6x to the 7th. So the only issue I see on this one is the plus sign. I need to change that to a minus, so I'm going to write that as f of x equals negative 12x squared over 1 minus negative 6x to the 7th. Again, I change it to minus so that I have negative and a negative, which would be a positive. So again, if I start with my basic form, 1 over 1 minus x, we know that's the sum n equals 0 to infinity of x to the n. Instead of x, I'm going to put in negative 6x to the 7th. So I have 1 over 1 minus negative 6x to the 7th. Everywhere I see an x, I have to put in that negative 6x to the 7th. So I have negative 6x to the 7th to the n. All right, and then I need to multiply this whole thing by the negative 12x squared. So negative 12x squared over 1 minus negative 6x to the 7th equals the sum n equals 0 to infinity, negative 12x squared, negative 6x to the 7th to the n. So again, technically I'm done, but I want to clean this up a little bit. So when I clean this up, I get the sum n equals 0 to infinity of negative 12 times negative 6 to the n times x to the 7n plus 2. Now to find my interval of convergence, I'm going to take that r value, the negative 6x to the 7th, do the absolute value of that. And I know that has to be less than 1. So that means absolute value of x to the 7th has to be less than 1/6. Remember, the negative drops because of the absolute value. And that tells me that absolute value of x has to be less than 1 over 6 to the 1/7. And that simply means that negative 1 over 6 to the 1/7 has to be less than x, has to be less than 1 over 6 to the 1/7. And that is my interval of convergence. All right, in number 6, we have x to the 7th over 8 plus x cubed. And again, I have an issue with the 8 and the plus sign, so I'm going to rewrite this to be f of x equals x to the 7th over 8 times 1 minus negative x cubed over 8. All right, and so now again, I'm going to start with the parentheses part after I start with my initial function. So 1 over 1 minus x is the sum n equals 0 to infinity x to the n. And then I'm going to replace that x with negative x cubed over 8. So I have 1 over 1 minus negative x cubed over 8 equals the sum n equals 0 to infinity of negative x cubed over 8 to the n. Again, wherever I saw the x, I put in that negative x cubed over 8. And then the last part is I have to multiply by this x to the 7th over 8. So I have x to the 7 over 8, 1 minus negative x cubed over 8 equals the sum n equals 0 to infinity of x to the 7 over 8 times negative x cubed over 8 to the n. Again, technically at that point I'm done, but I do want to write it in a nice power series form. So I'm going to get the sum n equals 0 to infinity. I see 1/8. That's from here. And then I also see negative 1/8 to the n. All right. And then I also see x to the 3n plus 7. All right. Now I can write that a little bit nicer if I wanted to. And I could say the sum n equals 0 to infinity of negative 1 to the n. And then I can say 1/8 to the n plus 1. And then x to the 3n plus 7. All right. And again, I just use properties of exponents to kind of work that out a little bit. All right, so then to find my interval of convergence, again, I'm taking the thing that's being raised to the n, which is this negative x cubed over 8. And notice when I do that, I always go back up to like the raw form of the equation so it's not all separated. I want everything that's being raised to the n to be included. So I have the absolute value of negative x cubed over 8 has to be less than 1, or I get absolute value of x cubed has to be less than 8. If I cube root both sides, I get absolute value of x has to be less than 2, which means that x has to be between negative 2 and 2. All right, last problem like this, and we'll move on to something else. We have f of x equals x to the 2/5 over 4 minus 3x squared. So again, I got to get rid of that 4. That 4 is really what's throwing me off because I know I need it to be a 1. So again, I'm going to rewrite this as f of x equals x to the 2/5 over 4 times 1 minus 3/4 x squared. All right, so once I have it in this nice form, again, I'm going to start building my function with our basic geometric. All right, and then everywhere I see an x, I'm going to put the 3/4 x squared. So I have 1 over 1 minus 3/4 x squared equals the sum n equals 0 to infinity 3/4 x squared to the n. And then I know I'm going to need to multiply it by this x to the 2/5 over 4. So I get x to the 2/5 over 4, 1 minus 3/4 x squared, which is the sum n equals 0 to infinity. Again, all I did was multiply by x to the 2/5 over 4, and then I leave everything else alone. All right, so once again, that technically is my final answer. I just want to rewrite it so that it looks a little bit more like a power series. So I'm going to say the sum n equals 0 to infinity, and I'm going to have 3 to the n. That comes from here. And then I have x to the 2n plus 2/5. All right, and then I also, in my denominator, I have 4 to the n plus 1. All right. And again, I could have written that a little differently. I could have written it instead of divided by 4 to the n plus 1, I could have multiplied by 1/4 to the n plus 1. It's just how you see it. All right, so lastly, I need to find that interval of convergence. So again, I'm taking the piece that was raised to the n, and I'm simply going to say that the absolute value of that, let me do it underneath. So the absolute value of 3/4 x squared has to be less than 1, which means the absolute value of x squared has to be less than 4/3, or the absolute value of x has to be less than 2 over root 3. which again simply means that negative 2 over root 3 has to be less than x, has to be less than 2 over root 3. All right, so moving on, we can also find derivatives and integrals of our power functions. And so the way that you do that is, again, you just build the series to start, and then you take the derivative of the series. And so for this problem, I already have the 1, I already have the minus. So I'm going to start by doing 1 over 1 minus x is our sum. N equals 0 to infinity, x to the n. And then I have 1 over 1 minus 3x to the fifth is the sum. N equals 0 to infinity of 3x to the fifth to the n. Then I got to multiply that by 5x. So I have 5x over 1 minus 3x to the fifth has to equal the sum. N equals 0 to infinity of 5x times 3x to the fifth to the n. Rewriting that to look more like a power series, I have, looks like I have 5 times 3 to the n times x to the 5n plus 1. All right, I get the 1 from right here. And so now I want to take the derivative of that. So g prime is just going to be the derivative of that sum. So the derivative of n equals 0 to infinity of 5 times 3 to the n times x to the 5n plus 1. Now notice we're taking the derivative in terms of x. Everything else we treat like a constant. So like the n is a constant. And so what I'm going to do is I need to focus on, just on this x piece. And if you remember taking the derivative, you simply drop your exponent down and then subtract 1. And so I'm going to end up with the sum, n equals 0 to infinity, 5 times 3 to the n, that's going to stay, times, I'm going to drop this exponent down. So this 5n plus 1, I'm going to drop it down to be 5n plus 1, x to the 5n, and it's just going to be 5n because remember you have to subtract 1 when you take the derivative from your exponent. And so that's our derivative. All right, next one, I need to rewrite this first. I'm going to rewrite it as g of x equals x to the 10th over 2 times 1 minus x squared over 2. All right, so then when I build my series, I have 1 over 1 minus x is my sum. N equals 0 to infinity of x to the n. And then I have 1 over 1 minus x squared over 2 is the sum. N equals 0 to infinity of x squared over 2 to the n. And then I got to multiply by x to the 10th over 2. So I get x to the 10th over 2, 1 minus x squared over 2 equals the sum. N equals 0 to infinity of x to the 10th over 2 times x squared over 2 to the n. All right, so making it look like a power series, I have sum n equals 0 to infinity, x to the 2n plus 10 over 2 to the n plus 1. All right, now if I have to take the derivative of this, again, all I'm going to do is focus on that x piece. So I get g prime of x equals the derivative of my summation and then I'm going to take that exponent and I'm going to drop it down so I get the sum n equals 0 to infinity. I'm going to have 2n plus 1 x to the 2n because I have to subtract 1 over 2 to the n plus 1. Oh, sorry, this should have been 10 here. And so this should be 9 when I subtract 1. I dropped the 0 for some reason. All right. So again, 2n plus 10 times x to the 2n plus 9, all over 2 to the n plus 1. All right, so for the last section, we have to find the integral. And so again, I'm going to build that power series. I'm going to start by rewriting. So I have x to the 4th over 9, 1 minus negative x squared over 9. And so then I have 1 over 1 minus x is my sum. N equals 0 to infinity, x to the n. Then I have 1 over 1 minus negative x squared over 9 is the sum n equals 0 to infinity, negative x squared over 9 to the n. And then I'm going to multiply that by x to the 4th over 9. So I have x to the 4th over 9, 1 minus negative x squared over 9. And that's just going to give me the sum n equals 0 to infinity, x to the 4th over 9, negative x squared over 9 to the n. And then rewriting that to look more like a power series, I have, it looks like I'm going to have negative 1 to the n from the top. And then I'm going to have x to the 2n plus 4 over 9 to the n plus 1. Alright, so now if I want to integrate that, I'm simply going to integrate that sum. And so remember, with integration, you add 1 to your exponent and then you divide by the new. So I'm going to have the integral of, I'm going to have the sum of negative 1 to the n, x to the 2n plus 5. Remember, you add 1 when you integrate, all over 9 to the n plus 1 times 2n plus 5, because we have to divide by our new exponent. And so that would be our integral. All right, very, very last problem, and we're done. We have h of x equals 7x over 3 times 1 minus, if I pull out that 3, I get 2x. All right, so then I start with the 1 over 1 minus x is our sum. And then I have 1 over 1 minus 2x would be the sum n equals 0 to infinity of 2x to the n. Alright, so then I'm going to multiply that by 7x over 3. And so I get the sum n equals 0 to infinity, 7x over 3 times 2x to the n. Again, writing that more like a power series, I would get the sum n equals 0 to infinity of 7/3 times 2 to the n times x to the n plus 1. Again, that plus 1 comes from right there. Alright, so now if I want to integrate my h of x, I'm simply integrating that sum. And again, remember, we're only focused on the piece that has x because we're integrating in terms of x. So I'm going to take that exponent, I'm going to add 1, and I'm going to divide by the new. And so when I do that, I get the sum n equals 0 to infinity, 7/3 times 2 to the n times x to the n plus 2, because I added 1, over my new exponent of n plus 2. And that's it. If you guys have questions, feel free to text me or email me. And then you guys need to also work on that first homework assignment in your homework packet. All right, look forward to seeing you guys soon.